So in the first problem, we'll be talking about radians. So for a radian, when the arc subtends theta, it is the radian. If half a circle, you get 3 radians. In half a circle, you get 3 radians plus a little bit, which gives you pi radians. And the radians describe the arc across from theta. So here, that would be the theta, which would be equal to 1 radian. That would be describing this. So that's 1 radian, that's 2 radians, that's 3 radians, and all of them combined is pi radians. For number 2, we're explaining the formula for the area of a sector of a circle. So the formula would be area equals radius squared theta over 2. So what this formula does is find the number of squared units it takes to fill a sector of a circle. So for example, in the circle to the left here, we are looking for the number of squared units it takes to fill up the 90-degree sector. So this is a 90-degree sector. We can see that's 90 degrees. And we're looking how many of these boxes it takes just to fill up this whole sector. That's what this formula solves. In question number 3, we're explaining the domains of a trig function. So some domains of a trig function is not all real numbers because you could get a negative number in that equation. So if you get a negative number, anything that is negative would cause the domain to not be all real numbers. So that's how that would happen. Now this isn't number 4, this is actually number 6, which is a little error by me. But if you look closely on the screen right here, we see that each line here, they're all the same line, they're all equal to each other. So when graphing each equation, you could clearly see that they're all the same line on the same graph. Therefore, when looking for the domain, all of them are equal to each other. So when you look for the domain, you actually get negative infinity, positive infinity. So yes, the lines will all be equal to each other. The domains are all equal. Thank you.